In this video, we're going to talk a little bit about vulnerabilities. Now, generally speaking, most vulnerabilities are flaws in a program that are related to some sort of a situation the developer did not consider. Occasionally, you have protocols that are actually flawed all by themselves, and you might uncover some sort of flaw in the underlying protocol. But the vast majority of vulnerabilities that you're going to see out there are made by average programmers. Now, the most common vulnerability is going to be a stack buffer overflow. So, what is this vulnerability? It goes kind of like this. You have a program, such as this very simple one I have here. In this program, you define some sort of buffer. So you have a buffer that you've defined. Perhaps that buffer is not large enough for all possible inputs. This can cause bugs in your program, but where things get really bad is when a user has control over this input. So whenever you allow a user control over your inputs, it's going to be very bad. In this program that I've written, it's a very simple C program. And by the way, C is used to write nearly every operating system on this planet. And because of that, you will find a lot of things such as stack buffer overflows and other things that can trace themselves back to the C programming language. So here, what I have is a very simple program. It has one function, which is called function. We'll come back to that in a second. And here we have the main function. So in C or C++ programs, the standard main function that gets called takes two parameters. The first parameter is a number of arguments that were passed. Traditionally, we call that argc. You can call it whatever you want, but that's what we normally call it. And then we have an array of strings, which looks a little funny. You see character ***, which actually means it's a pointer to a pointer. Because the way strings are handled in the C language is to treat them as an array, that's really just a simple list in memory of characters. And each character is normally encoded in ASCII, and it takes 1 byte for each character of your string. All I'm doing here is accepting input from the user. And this is a horrible program, by the way, because I'm just calling function, and I don't check anything. So if you don't pass in a parameter, this program will actually crash. So I call function, and I take the very first argument you passed in. And that is my first argument to that call. Now, some of you might wonder what is with argv1, because you know that these arrays are based 0. And the answer is argv0 points to the name of the program that you're running. So argv1 is that first argument. I also passed in 42 and pi to 3 digits. That will become apparent in later videos why I did that. So here in our function, we take this parameter, which is a string. This is controlled by the user. That is the danger. Never allow the user control over any inputs to other functions, especially if they could overflow or have some other issues. So you want to check everything the user ever inputs. I then create a local buffer called local. And here I said, let's make it 1,000 bytes long. Let me go ahead and reduce that to make our example a little bit easier. And then I call stir copy. Now this function will copy from the second parameter, from param, to my buffer local. Here's the problem. I've allocated 10 bytes. 10 bytes gets me 9 characters plus a null terminator. So C strings normally want a null terminator, which is a value of 0 at the end of the string. And that's the way of saying, hey, we're done here. So when you do a copy, it will keep copying until it hits that null. If I put in 9 characters or less, everything's fine. If I put in 10 or more characters, everything might not be fine because now I'm going to overflow this buffer. So anything that's in memory right after buffer could be overwritten. We're going to take a short break, and when we come back, we're going to show you how to compile this program and cause it to crash.